Hey everybody, this is Mr. Schaefer. I was wondering if you could help me write the quadratic formula. This is a formula that we really should have memorized in order to have success at solving quadratic equations. So to help you out, I'm going to write it down next to this expression right here. X equals, we're looking for solutions for x, and it begins opposite of b plus or minus the square root of b squared minus 4ac. And all of that is divided by 2 times a. So there's the quadratic formula. I'd like to take some time today in this video lesson to just go through a couple examples of how the quadratic formula can be used to help us solve quadratic equations. So again, here it is. It's a method that can be used to solve any quadratic equation that is in standard form. Now let's not forget that our quadratic equation should be written in standard form before we dive into using the quadratic formula, because the a, b, and c values are all of the coefficients, coefficients and constants in the quadratic equation before we try to solve it. So standard form, here it is, ax squared there we go, ax squared plus bx plus c equals 0. Now, step 2 here says to compute the discriminant. And again, the b squared minus 4ac, that's called the discriminant, it's under the radical. That is going to tell us how many solutions there are. That's not something that you necessarily have to do each time you solve a quadratic equation with the quadratic formula. It's nice to know the number of solutions so that we can expect, but that's actually going to be part of the solving process. So put a little star by step 2. That's maybe something that would be optional. That would be information that would be helpful, but not necessarily required as we go through the entire process. So step 3 says to substitute values into the quadratic formula. So that means plug in a, plug in b, and plug in c, the coefficients. And once again, we see them right here. A, b, and c would be the constant. Now, in calculator problems, the question might ask you to round to 2 decimal places or to 3 decimal places if the answer involves some kind of simplified radical. So it's possible to get exact answers. It's possible to also have rounded answers if we have radicals that we want to compute with the calculator. Now, let's look at number 1 together, and I'll take you through the entire procedure. We'll kind of talk about how to solve this equation, again, using the quadratic formula. So to begin, example 1, notice it's not yet in standard form because we want to get one side equal to 0. So if I subtract 8 from both sides, then we'll have one side equal to 0. The discriminant is going to be b squared minus 4ac. I'll go ahead and compute that since we're here. So 5 squared minus 4 times 3 times negative 8. So that'll be 25 minus 4 times 3 times negative 8. That double negative is really going to end up being a positive. And when we're finished, the discriminant is going to be a 121. A positive number, so we should expect 2 solutions. 2 solutions because our discriminant, b squared minus 4ac, is positive. All right, and then finally down here it just says negative b, opposite of b, and then 2 times a. Well, opposite of b is negative 5. And then 2 times a would be 2 times 3, or 6. We're going to use those numbers in the formula. And let's now come over here to the right-hand side of the paper, and we'll use all this information and actually solve for x. So x equals opposite of b plus or minus b squared, the square root of b squared minus 4ac. And again, we computed that earlier, but I'll just write it down again. So 25 minus 4 times 3 times negative 8, all underneath the radical there. And divide that by 2 times a. So now I have all the A and the B and the C values are all plugged in to the quadratic formula. And really my job now is just to clean this mess up. I'm going to try to simplify as much as I can. So let's see how this all kind of breaks down. All right, -5 plus or minus, we said that was 121 in that expression. So root 121, and that's all divided by 6. Now radical 121 is a perfect square, and that's exactly equal to 11. So now I have -5 plus or minus just the number 11 all over 6, and that actually will lead to 2 different solutions, and here's how it works. I might suggest we draw 2 arrows. So I have -5 plus 11 all over 6. And then down here we have -5 minus 11 all over 6. That plus or minus is important because whenever we take a square root in solving quadratic equations, we need to make sure that we have that plus or minus on the radical. And it just kind of gets carried down into the problem. Well, now, when I'm ready to actually find the solutions, I'm going to break apart that plus or minus because one solution is going to be derived with that plus sign. The other solution will be derived with that minus sign, like I'm doing right here. So to finish the whole problem, -5 plus 11 is 6. 6 over 6 is exactly equal to 1. Down below, I have -16 over 6, and that will reduce to -8/3. So those are my 2 solutions, and I'll write them down in the blank right here. Solutions are going to be 1 and -8/3. Sometimes we can use these sort of fancy brackets to group them as solutions. Don't use parentheses because when we use parentheses like 1 comma -8/3 this way, then we're talking about an ordered pair, and that is not what we're doing here. We're just talking about the solutions x equals 1 and x equals -8/3. In fact, we could also write our solutions in that manner. So we could say x equals 1, or we can say x equals -8/3. So that would be how you would sort of formally write the notation of what solutions you found. Bottom line is this. If I plug in 1, and if I plug in -8/3 way back here to my original problem, I'll get a true statement. I found the solutions that make that equation true. And again, we said from the discriminant calculation that we should have 2 solutions, and sure enough, we did end up with 2 solutions in the end. So those are some great ways to check that what you did in the way of computation actually worked and that you that you were on the right track. Okay, I'd like to do one other example with you to kind of show you how this works. And for that one, I think we'll go to problem. Maybe we'll do 2 more examples. Let's look at problem number 4. All right, let's get this thing in standard form. I'll move a little bit quicker this time. So I'm going to subtract 5x from both sides. And I'll have x squared minus 1x. I'm going to add 3 to both sides. Minus 4, and that'll equal 0. So I've got my standard form. I'm going to skip the discriminant for now. I'm going to skip this opposite of b, and I'm going to skip the 2a, just because I'll do all that in my procedure of solving with the quadratic formula. So here's my equation, x squared minus x minus 4. Let's see what we end up with here. So opposite of b, well, the b value is -1. Opposite, excuse me, opposite of b would be, oh, wait, one mistake here. Glad I caught that early. -6x minus 5x is positive 1x. There we go. So it should be x squared plus x minus 4. Okay, which means that when I go to write down opposite of b, it's actually -1. That goes right up here. All right, so opposite of b, plus or minus, and here's the discriminant, b squared minus 4ac. So 1 squared minus 4 times 1 times negative 4. And all divided by 2 times a. 2 times a would just be 2 times 1. So there are the pieces in this formula. And can we clean this up? Plus or minus the square root of the square root of 17. That'll become 1 plus 16. That's 1 plus 16. Negative 4 times 1 times negative 4 is positive 16. That's all under the radical. So I have a root 17 all divided by 2. That root 17 cannot be simplified. So I really have my exact answers. That's as far as I can go. So I can box that in and just put that right here on the answer blank because those are the two exact answers. If you want to separate them, we could say negative 1 plus root 17 all divided by 2, and then negative 1 minus root 17 all divided by 2. There are my two solutions. So you can either box this entire expression in here like that and leave that alone, or you could just kind of bracket those two as the two separate solutions. They both mean the same thing, and notation-wise, both are okay. Now, because we have a little section here that says rounded, let's actually compute the approximate value of these solutions. So on your calculator, you would simply type in negative 1 plus root 17, and then divide that number by 2. And I believe it's 1.56 as a rounded decimal answer. For the second solution, negative 1 minus root 17, again, all divided by 2. And that solution ends up being negative 2.56. So I've rounded approximate values. These are approximations. So those decimal answers are just, I'm approximating these two solutions. If I want exact answers, I leave the whole expression with that square root of 17 in there. So I leave it as it is in red. If I want rounded answers, I can actually then use the calculator to type out what those are going to be equivalent to. All right, and finally, I thought I would maybe stop there, but I have one last thing to kind of just talk about with you with example number 5. It is possible that there might be no solutions. Okay, here's our standard form. It's already good to go. 6x squared plus 2x plus 5 equals 0. So we are good. It's already in standard form. Let's dive into the quadratic formula. X equals opposite of b plus or minus b squared minus 4ac all divided by 2 times a. Now, if I look at this here carefully, and try to break it down, I'll have negative 2 plus or minus the square root. We can check this on the calculator. 4 minus 4 times 30 would be negative 116, and all that's divided by 12. I'm going to stop right here. We have no solutions because you can't have the square root of a negative number. If I have the square root of something like negative 81, it is not true that that equals negative 9. We can't have negatives in the radical. So statements like that don't exist. We say that there's no real solutions, at least within the real number system, they don't exist. So here, my answer, no solution. No real solution, because we are staying in the real number system for algebra 1 right now. And the reason that we know that is because this discriminant value, the number in that radical, ends up being negative. Remember, whenever b squared minus 4ac is negative, in this case, negative 116 is less than 0. Whenever that happens, then we have no solutions or no x-intercepts on that parabola. Okay, so there's a kind of a rundown of a couple examples of the quadratic formula. It can be complicated, especially when we first learn it. So be patient and work through a number of examples and just practice memorizing the formula and applying it. And then in time, I think these problems will become just second nature to you as another way to solve a quadratic equation.